This is Transformations of Graphs of Linear Functions, Part 2. And today we're going to be talking about stretching and shrinking. So first we're going to look at horizontal stretches and shrinks. So we can take our parent function and transform it by multiplying our x-coordinates, which are our inputs, by the same factor. We're going to call this factor a. So a is a constant. If a is greater than 1, it's going to actually horizontally shrink our graph. The graph will literally shrink towards the y-axis. So if this black line here is our parent function, and we take our inputs and we multiply by a constant that we're going to call a, if a is greater than 1, this guy's actually going to shrink up towards the y-axis. Now if that constant is something between 0 and 1, it's actually going to horizontally stretch our graph. So here's our parent function. If we multiply by something that's between 0 and 1, all of our inputs, it's actually going to take this guy and stretch him out away from the y-axis. We're also going to talk about vertical stretches and shrinks. We can take our parent function and transform it by multiplying all of our y-coordinates, our outputs, by the same factor a. And when we multiply the outputs by this constant, if the constant is greater than 1, it's going to be a vertical stretch. So here we have our parent function, and if we multiply all of the outputs by a, and a is greater than 1, it's actually going to stretch our, actually going to stretch our guy away from the x-axis. But if that constant is between 0 and 1, it's actually going to be a vertical shrink because the graph is going to shrink towards the x-axis. So here's our parent, and it's going to shrink towards the x-axis. In each case here, the x-intercept stays the same. So let's take a look at some examples. So here our parent function is f of x equals x minus 1. They're asking us to graph g of x equals f times 1/3 x, and h of x equals 3 times f of x. So here we're multiplying our inputs by 1/3, and here we're multiplying our outputs by 3. So we're going to see what happens on these guys. So I started off by coming up with some inputs. I picked -3, 0, and 3, and I plugged them into my parent function. And I got the outputs of -4, -1, and 2. So when I plugged them in, I had to do x minus 1. So -3 minus 1 gave me -4, 0 minus 1 gave me -1, and 3 minus 1 gave me 2. And then I graphed my parent functions on both of these graphs here. The next thing I did was I figured out, what if I took the inputs and I multiplied them by 1/3 before I put them into the parent function? So I did exactly that. So -3 times 1/3 gave me -1, and when I plugged -1 in here, -1 minus 1 gave me -2. When I plugged in 0, 0 times 1/3 was still 0, and 0 minus 1 gave me -1. And then I graphed 3. I put 3 into here. 3 times 1/3 was 1, and 1 minus 1 was 0. And now I'm going to graph that function. So my g of x had an input -3 and an output -2. And then I had 0, -1. That one stayed the same. And I had 3, 0. So I actually multiplied by 1/3, and this guy actually stretched away from the y-axis, and my y-intercept stayed the same. So this is a horizontal stretch. So let's take a look at this guy. So this was multiplying our outputs by 3. So I took all of my outputs from my original f of x and multiplied them by 3. So I got Negative 4 went to negative 12, negative 1 went to negative 3, and 2 went to 6. So let's try putting these guys on the graph. So I now have negative 3, negative 12. I've got 0, negative 3. And I've got 3, 6. So on this one, my x-intercept stayed the same, and this guy actually went from being here to stretching towards the y-axis. So this is a vertical stretch. All right, let's take a look at another example. So this time our parent function is f of x equals x plus 2, and we're asked to graph g of x equals f and then 4 times x, so we're multiplying our inputs by 4, and h of x equals half times f of x. So we're actually being asked to half our outputs. So I started by plugging in some inputs. This time I picked negative 2, 0, and 2. I plugged them all into my parent function. I got my outputs, and I graphed my two parent functions on both of these graphs. Next, I went to my g of x, and I decided to multiply all my inputs by 4 before plugging them back into the parent function. So I took negative 2, multiplied it by 4, I got negative 8, and negative 8 plus 2 gave me negative 6. So 4 times 0 was 0, 0 plus 2 gave me 0. 4 times 2 was 8, 8 plus 2 gave me 10. So let's graph this function. So I've got negative 2, negative 6. I've got 0, 2. This point is the same. The y-intercept is the same. And I've got 2, 10. So this one is actually a horizontal shrink because it's shrinking towards the y-axis. All right, let's look at one more. We have h of x equals half f of x. So I want to take all my outputs from the original parent function and cut them in half. Now I have negative 2, 0. So my x-intercept is the same. 0, 1, and 2, 2. So this one, it's actually going towards our x-axis. This is a vertical shrink. Remember, if I do something to the inputs, it's going to actually horizontally stretch or shrink my graph. If I do something to the outputs, it's going to vertically stretch or shrink my graph.